Little basic right triangle trig we're working with today. So, what is that again? Again, well, there's a right angle in every one of them. We're not going to be doing non-right triangles trig. You need to take a trig class if you want to get into that. So, right triangle trig, for our purposes, is just the relationship, bonding relationships. It's almost like the Dr. Phil of math or something, I don't know, between the sides and angles of a right triangle. Not any triangle, just this particular type. Because if it's not right triangle trig, we have a different thing we deal with those. And unfortunately, we don't get to deal with those here this last week or so. So when we're doing right triangle trig, we're going to be making ratios. Now, a ratio is just a very fancy word for a fraction between some sides in the triangle. But here's the kicker. All of the sides of a right triangle have a specific name and a specific relationship based on where you start. So, when we're doing sine, cosine, or tangent, those are our three basic trig functions we're going to be working with. We are going to be working with the following ratios. When we're dealing with sine, okay, we use the opposite side over the hypotenuse. You're going to have a picture to work with here on the side in a minute to be able to reference as we're looking at this. So for the moment, just kind of jot these down and we'll color code this in a minute. Cosine is adjacent over hypotenuse. That's right, I heard it. And tangent is opposite over adjacent. But here's the deal. Opposite and adjacent depend on the angle. Depending on which angle I'm looking at it from, those change. So those are going to be a little inconsistent. The one consistency we're going to have throughout this, though, is the hypotenuse, because it's always across from the right angle, and it's always the biggest side. Oh, dear. This video is going to be like those old Chinese movies where their mouths move and then the words come. That's us here, too. I say it, and then it magically appears. So, how do I tell with these sides what's what? Let's start with these parts. Across from the right angle, the longest side is my hypotenuse. Always in the same place, no matter what angle we're starting at. However, with our adjacent and our opposite, it's going to depend which angle I start with. This is where we're going to bring the colors into play. So take one of your colors, color in this first angle. That is what's called our reference angle. And so when we're looking at opposite and adjacent, opposite is what you would think it is. Here's my angle. If I go opposite to it, that's my opposite. And adjacent just means it's connected to. So this side is connected to my angle. Let's see how I can twist myself here. Not bad. So if the blue angle is the angle we're working with, this is opposite, this is adjacent. However, if that angle changes, if that angle is down here on mine in red world instead, adjacent and opposite switch. Because now, if I go across from my angle, that is now the opposite side. And if I go with the side that connects to it, that's adjacent. That's the one part of this I have to be careful with. Pay close attention to what angle measure we're working with. So, if you are asked, and you will be at some point, to find the sine, the cosine, or the tangent, there will be numbers on your sides. So if we bump up here a bit. So if I'm looking for the sine, cosine, and tangent of A, the sine is opposite 3 over my hypotenuse. Maybe I even label them opposite, hypotenuse, adjacent. Never a terrible idea. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. Just making the fractions and leaving them. Don't need decimals, don't need to do anything else fancy. However, if the angle moves, so does my opposite and adjacent. But the trig functions don't. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And that's all there is to finding your basic trig ratios. Nothing too bad. Main thing here, just getting used to what sides am I using and how do I find that adjacent and opposite. But then the challenge becomes actually using it. So we are going to flip ahead here slightly to page 3 for the second half of our day 1 lesson and chat about how do I find a missing side if I have one. So, still in a right triangle. If I have one angle, just not the right angle, and one side, you can solve for any other side. If I have opposite, I can find adjacent or the hypotenuse, and vice versa. So what we're going to do here is we're going to do the first example while we're filling in the steps so we can kind of see how this works. So here, steps to solve for the missing side. Number 1. Okay, we're going to label the sides. So on this first one, wherever you see the angle measure, that's the angle we're working with. So when you go to label, there's my opposite, there's my hypotenuse, here's my adjacent. Get those labeled first. Then identify what trig ratio you're going to use. Am I using sine? Am I using cosine? Am I using tangent? Well, here I've got adjacent and hypotenuse. So if I need to look, I can look at my front page, or I put the initials up there for them on the front. Adjacent and hypotenuse would be cosine of 30 degrees is adjacent over hypotenuse. And my job is going to become to get x alone so I can know what the value is. So currently I'm dividing x by 186. What's my opposite going to be? Multiply. In its algebra, whatever we do to one side, we do to both. So I get there. And now I'm going to let the calculator do the work. But here's the kicker. You have got to make sure your calculator is in the right mode when you start. So when we get it turned on, mode is up here next to second. Make sure that your calculator is in degree mode. If it's in radian, if you showed up and it looked like this, go over to degree and hit enter to make sure you're in degree mode. Otherwise, all your measurements are going to be off. Okay? Once we've got that locked in, we can get out of there by doing second in mode. That'll always help us escape. And we type in exactly what we see here. 186, cosine right above the parenthesis. Normally round to the nearest tenth with those. But that's it. That's going to be our main challenge. So, take a moment. Oh, can I get it all at the same time? I think I can. Take a moment. I will freeze frame here. Try just to initially set up number 1 right below it. We'll unfreeze back here in just a moment. Making sure that I don't do anything bad here. So as you start to finish that one up, label our sides, get our ratio set up, and we're through that. You're like, okay, so Hardy, I'm sensing a pattern here. So when I set these up, I'm just going to multiply by that one number times my trig function, and I'm going to be done. Yes and no. Sometimes that'll be true, depending on what sides we have to use and where your x is at. What if there'd be a situation, though, where the x isn't on the top, up in the numerator? Yes, that can happen. So, let's play with another one. Back down here for a moment. Again, mark your angle that's been given. Label your hypotenuse. Label your opposite. Adjacent's the only one I got left. And the two sides where you have values, opposite and adjacent. If I take a peek over, that looks like tangent to me. So the tangent of 23 is opposite over adjacent. Now, here's where I got to be careful. If I look at the one right next to it, we multiplied by whatever was in the denominator. We want to take care of that. You're like, but I don't want to do that with x. I want to do it with the 55. We will. We just got to wait a step for it. So, yes, we are going to multiply both sides by x to get that x out of the denominator, because that is yucky to deal with. But you're like, wait, I don't have x solved for yet then. You're right. We have one more step to do. I'm multiplying x times the tangent of 23. The opposite of multiplying x by that would be to divide. So I do have a possible trick for you here in a minute, but before we do that, let's get this one typed in. 55 divided by the tangent of 23. And I'm ready to go. So here's the possible trick. Again, this works every time. This is fine. For those of you that like finding a shortcut, though, here's how you can tell what the shortcut's going to be. When you set up your trig ratio, if x is in the numerator, you're just going to multiply these two values together every time. It'll never change. If x is in the denominator when you set your trig ratio up, you're always going to take this value divided by the trig function. It will work that way every time. But again, if that's not your thing, remembering a pattern like that, just do the algebra. So, for instance, on 2, if I was doing that, arc my angle, arc my sides, I've got adjacent and hypotenuse, which is cosine. So if you were in shortcut mode, I'm still going to show the other way as well, but if you were in shortcut mode, you'd be like, okay, x is in the denominator, so x is going to be 30 divided by the cosine of 58. I will show my work after this answer message. And I push myself off the screen. So just to see again where that comes from, if I was doing algebra, I'd need x out of the denominator. We'd multiply by x. But now to get x alone, I'm multiplying it by the cosine of 58, and I need to undo that. X is alone. That's where this is coming from to get my solution. So for finding our regular right triangle trig sides, that's going to be the route we go. Tomorrow we'll be doing with angles and maybe a little bit of application stuff.